Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Imagine standing beneath a starry night and pointing toward the nearest star beyond our sun, Alpha Centauri, knowing that with current technology, a spacecraft from Earth would take tens of thousands of years to get there. Tens of thousands of years. That's longer than all of recorded human history just to reach one neighboring star. For decades, this immense distance has made interstellar travel feel like pure science fiction. But today, an exciting breakthrough is bringing that science fiction a little closer to reality. It involves something right out of a cosmic fairy tale. A sail made of light. Yes, light. Instead of catching the wind, this sail catches photons, the particles of light. And it just might slash interstellar journey times from millennia to mere decades. It sounds unbelievable, so let's dive into how it works and why scientists are so excited. First, what exactly is a light sail? Picture the delicate sails of a sailboat, but make them ultrathin, mirror-like sheets designed to catch light instead of wind. When sunlight, or an even more powerful laser beam, hits a reflective sail in space, it pushes on it, ever so gently. There's no air in space, but light itself carries momentum. Normally, we never notice light's push because everything around us is too heavy and light's pressure is tiny. But if you have a big, extremely lightweight sail in the vacuum of space, those countless photons streaming from a star or laser can actually propel it forward. It's a continuous push that doesn't require any fuel. The craft just keeps accelerating as long as the light shines on it. For a long time, light sails have been a theoretical idea to achieve incredible speeds, potentially a significant fraction of the speed of light, without carrying tons of rocket fuel. The concept has been demonstrated on a small scale. Some prototype solar sails have unfurled in space before, but reaching another star needs something far more advanced than anything flown to date. Now here's the breakthrough. A team of researchers has developed a new kind of light sail material and design that could be a game changer. In a lab, they created an ultra-thin, ultralight sail that's pushing the limits of engineering. How thin? Well, the prototype is only about 200 nanometers thick. That's roughly 1/500th of the thickness of a sheet of paper, or even thinner than a single human hair. Imagine a silky sheet so gossamer thin, you could almost see through it. Yet it's strong enough to survive being blasted by intense light. The entire sail the researchers made is just a few centimeters across, about the size of a drink coaster. But it's not the size that matters right now. It's the principles behind it. This little square of material is highly reflective and astonishingly light. Those properties are exactly what you want for a light sail. The more it reflects light, instead of absorbing it, the more momentum it gains from each photon hit. And the lighter it is, the easier it is to accelerate. What's really clever is how they achieved those properties. The team didn't just use any foil. They engineered the sail at the nanoscale with a special pattern of tiny holes. It might sound strange that poking billions of teeny holes in a sail would make it better, but it does. These holes shave off weight, making the sail even lighter, while also interacting with the light in a way that increases the overall push. Think of it like an ultrafine lace or mesh, designed not for fashion, but for physics. By precisely tuning the pattern of this nanomesh, the scientists found a sweet spot that maximizes thrust and minimizes weight. The end result is a super reflective photon catcher that's ridiculously light for its surface area. It's like a mirror merged with a feather, except even a feather would be heavy in comparison. To build such a thing, they had to turn to cutting-edge materials. The sail is made from a substance called silicon-nitride, which is a bit of a superstar material in high-tech circles. Silicon-nitride is extremely lightweight, but also durable and heat-resistant. Crucial qualities if you're going to fling something out of Earth's orbit and zap it with powerful lasers. This material had to remain intact under intense radiation and not tear apart during the acceleration. Using silicon-nitride, the team could make a membrane that's just one molecule thick, more or less, yet strong enough to hold its shape. If you held this sail in your hand, it would be almost weightless. You'd barely feel it, like a wisp of dragonfly wing. But designing the perfect light sail is an incredibly complex puzzle. There's a trade-off. You want it as light as possible, but you also want it to reflect as much light as possible. Add too many holes or make it too thin, it might lose reflectivity or tear. Make it too thick or solid, it's heavier and slower. To solve this puzzle, the researchers enlisted the help of artificial intelligence. They used AI algorithms to test countless hole patterns and configurations in simulation, essentially letting a computer brainstorm designs far more quickly than humans alone could. Through this AI-driven optimization, they arrived at a pattern of nano-holes that gives the best of both worlds. An ideal balance where the sail is both highly reflective and has very little mass. It's like tuning a musical instrument to get the perfect note. Except here, the instrument is a sail, and the note is maximum acceleration. And so, what does all this meticulous engineering translate to in terms of performance? In essence, it means a light sail could handle being blasted by a high-powered laser and reach mind-boggling speeds. The researchers calculated that a larger version of their sail, if scaled up to a few meters across, imagine something maybe like a big kite size, but weightless and reflective, could potentially be accelerated to a few tens of % of the speed of light. Let's put that into perspective. Light speed is about 300,000 kilometers per second. 10% of that is 30,000 kilometers s. At that speed, you could zip from Earth to the Moon in about a couple of seconds. Now, realistically, they're talking maybe 20% of light speed for an interstellar mission concept. That's 60,000 kilometers s. At that velocity, you could travel the distance to Alpha Centauri, over 4 light years away, in around 20 to 30 years. 20 to 30 years. Suddenly, a journey that would outlast human civilization with conventional rockets could be done within 1 generation. That's still a long voyage. Imagine launching a probe today and not arriving until a few decades later. But it is absolutely revolutionary compared to anything we've ever considered feasible before. Of course, the prototype they built in the lab isn't zooming off to another star just yet. The piece they made is small, a few centimeters wide, but the whole point was to prove the concept and solve the key engineering challenges on a small scale. One challenge was manufacturing. How do you even make something full of nanoscale details without it costing a fortune or taking years? Traditional microfabrication, like the kind used to make computer chips or tiny optical devices, can be extremely slow and expensive, especially for something as large as a sail. In fact, some complex nanostructures might normally take years of painstaking work to produce in appreciable sizes. But this team came up with a new fabrication technique using a special gas-based etching process. In simple terms, they used reactive gases to eat away patterns in the material in one go, which is much quicker than some step-by-step lithography processes. The result? They can manufacture a sail like this in about 1 day. Not years, not months, but literally within a day, and at a fraction of the cost of older methods. This was a huge leap forward, because if you're going to need not one but dozens or hundreds of sails to explore the stars, you need a way to make them efficiently. Think of it as moving from crafting one artisanal sail by hand to having a machine that can mass produce them like cookies, consistently and cheaply. Another big win. The sail they produced has a record-breaking aspect ratio, meaning the contrast between its size and its thickness. They managed to create a sheet that is centimeters in span, but only nanometers thick. That's like having a piece of foil as wide as your hand, but thousands of times thinner than a sheet of paper. Why does that matter? Because a high aspect ratio and low mass are exactly what you need to achieve high speeds with light pressure. It shows that in principle, you can have a large, incredibly light sail that stays in one piece. Achieving this kind of delicate structure without it collapsing or tearing was a significant validation of their approach. Now, let's talk about the implications. This advancement aligns with an ambitious real-world plan you may have heard of. Breakthrough Starshot. Breakthrough Starshot is a project conceived by scientists and futurists to send tiny chip-sized spacecraft to another star, propelled by light sails and Earth-based lasers. The idea is to use a powerful array of lasers on Earth to shoot a beam at a sail, accelerate a tiny attached probe to maybe 20% the speed of light, and send it towards, say, Alpha Centauri. Up until now, Starshot and similar concepts were largely theoretical or stuck on the drawing board because the technology for the sails and the lasers was still catching up. But here we have exactly what the doctor ordered, a sail design that could, in theory, handle that intense laser push and achieve the required speed. The team's new sail is like a prototype blueprint for what Starshot sails could be. And because the manufacturing method is scalable, we're not talking about just making one perfect sail after years of work. We could potentially manufacture many sails, maybe even an assembly line style. If one tiny probe is good, a fleet of 50 or 100 little star chasers would be even better. We could send them to multiple targets or have backups in case some don't make it. Let that sink in. We are on the cusp of being able to reach other stars on a time scale of a human lifetime. Our great-grandparents looked up and pretty much knew we were stuck in our solar system for the foreseeable future. Even getting to the moon or Mars was a daunting dream. Now our generation is seriously talking about interstellar exploration schemes. There's still a long way to go. This new light sail needs to be scaled up from a postage stamp in the lab to a full-scale sail in space. And those giant lasers need to be built and tested. And then there are a million practical considerations. How do we aim the sail accurately at a tiny target light years away? How do we slow it down when it gets there? Or do we even try? Can a microchip-sized spacecraft survive the journey and still phone home with data once it whips past the target star system? All of those are challenges researchers are actively pondering right now. But the critical takeaway today is that one of the biggest hurdles, having a material that can serve as a fast, efficient sail, is being overcome. It's a breathtaking prospect. Just imagine a wafer-thin craft, no bigger than a fingernail, attached to a shimmering gossamer sail, perhaps a few meters wide. A few minutes after launch, a battery of lasers on Earth fires a concentrated beam of light. In moments, the tiny spacecraft feels a shove and takes off, rapidly gaining speed. Within hours, it's moving faster than any human-made object ever has. It cruises out of the solar system in days, and then just keeps going, coasting across the interstellar dark. 20 or so years later, if all goes well, that little messenger will streak by a new sun, capturing humanity's first close-up images of an alien world, perhaps orbiting Proxima Centauri or another nearby star. Even if it can't stop, it might be able to transmit priceless data back to Earth. A postcard from another solar system. That sounds like pure fantasy, but with each technical breakthrough like this light sail, it edges closer to reality. This new light sail technology also showcases how innovative thinking and advanced tools like AI are enabling us to solve impossible problems. Who would have thought that drilling billions of holes in a piece of film could be the key to reaching another star? Or that teaching a computer to optimize a pattern would open the gateway to interstellar speeds? It's a wonderful reminder that the frontier of exploration is often driven by these unorthodox, creative solutions. So, what's next? The researchers will likely try to scale up their design, test it under space-like conditions, vacuum chambers, laser hits, etc., and collaborate with others working on laser propulsion systems. We might see a demo in space perhaps in the coming years. Maybe not to another star yet, but a Lightsail accelerated to high speed across our solar system as a proof of concept. Each step will tell us what works and what needs tweaking. And there will be surprises and setbacks, no doubt. Space engineering is hard. But the momentum behind this idea is real and growing. Standing here now, it's awe-inspiring to think that the stars are no longer just distant points of light we can only dream about. In the future, they might become destinations, places we can actually plan to visit, even if vicariously through our robotic probes. Will our first journey to a distant star be on the wings of a light sail, driven by pure light itself? It's a profound thought. We've gone from carving wooden ships to sail Earth's oceans to devising nanotech sails to cross the cosmic ocean. If light sails do pave our way to the stars, the next question is, what might we find when we get there? And how will it change us back here at home, knowing we become an interstellar species? It's a journey we're just beginning to imagine, one brilliant push of light at a time. So would you ever volunteer to ride a beam of light to another star, if you could? Or send your robotic emissary to explore the unknown? The countdown to the cosmos is on, and it's powered by the light that shines on us all.